Section 5.5 Applications of exponential functions. This one we are going to solve problems involving growth, decay, and elastic demand. For the exponential growth and decay, we consider the function y in the form of c times e to the power kt for the growth, and y equals c times e to the power negative kt. So the sign superscript or the power of the e as positive sign represent the growth of the function or grows exponentially. For the negative side that appears as the exponent of the e is representing the declining or decaying of the number exponentially. For the derivative of the function y, let's do a quick one here. To find y prime, c as a constant or the constant multiple, multiplied by the derivative with respect to t of e to the power kt. We use the chain rule, and this form is in a form of e to the power of the g of the t. The derivative, we're gonna need the g prime of the t. So then the derivative of the y or the y prime will be c multiplied by e to the power kt and multiplied by k, which is the derivative of the function g. Or we can rewrite it as k multiplied by c e to the power kt. If we write in this form, we can see that the y prime will be k multiplied by the original y term, which is in the box here. We can see this as a relationship of the derivative, which is the rate of change. The rate of change of the quantity is proportional to the quantity. The proportional means it related by the linear number or is the multiple k of the value y. Similar to the case of the decay, so if y is c times e to the negative kt, or y is in the form of c times e to the function g of the t, where the g of t is negative kt. Therefore, the g prime is negative k. The y prime, which is the derivative of the e to the power gt with respect to t, will be obtained as the e to the power gt multiplied by g prime of the t, and replace the gt with the negative kt, the g prime replaced with the negative k, and we can simplify to be negative the value k times e c times e to the negative kt, which is exactly the same as negative k multiplied by y. So this is the relationship of the rate of change and the quantity itself. So we can say the rate of change of the quantity y is proportional to the quantity y. Let's see example. So the first example here, we suppose that a population of rabbits grow exponentially. That means the rate of population growth depends on the size of the population. For this part, we can interpret it as if we let y be the population of the rabbit, the rate of change of population or the y prime proportional means equals the constant multiple to the population itself, or we see this as the y prime equals k times y. Further, suppose that on Monday at 8 a.m., so we make a list here. So Monday, 8 a.m., the population or the y equals 100. And 8 a.m. on Wednesday, same time, but 2 days later, y is 130. That means the population is growing. We are going to find the exponential function, which is in the form of y equals c multiplied by e to the power kt. Recall this is a growing quantity or the exponential growth. So we're going to have the positive k as a power of the exponential. We are going to find the function y equals c times e to the kt that represents the rapid population at time t. T measure in days from Monday at 8 a.m. So that means when y equals 100, t equals 0, and then 2 days later, t equals 2, y is 130. That tells us we have two order pairs, 0, 100, and 2, 130. To find, in part A, we're going to find y equals c times e to the kt. We have two unknowns. We're going to have to know what is the value c and what is the value k. To use these two order pairs. The first order pair, if t equals 0, y is going to be 100 and replace the t with the value 0. Then we get c times e to the power 0, which is c times 1 or c. Now we get the value c as 100. We set it aside. This number is known. And next, we're going to get the second order pair. Use the second order pair to find another variable or the number for the k. So in this case, 20 is 2. The y is 130. Replace it in this formula of the function that we're going to find. So y is 130. C we already know from using the t equals 0, y equals 100. So we're going to replace c with 100 and multiply by e to the power k times 2, which is k multiplied by 2 or 2k. And we write it as 100 times e to the power 2k. At this point, we are going to solve for k. To solve for k, we're going to have to divide both sides by 100. Divide both sides by 100. And then simplify the left-hand side as 1.3 equals e to the power 2k. Now we get the exponential equation. To solve the exponential equation or to solve for k, we are going to apply the natural log both sides of the equation. When we apply the natural log both sides, use the property that the natural log of e to the power quantity equals that quantity. As this one is called the cancellation law, the log and e cancel each other. So then the left-hand side becomes natural log of the natural log of 1.3 equals, cross this out to be 2k, or k equals the natural log of 1.3 quantity all divided by 2. And put in the calculator, we get the number. I'm going to share the screen real quick for the calculator. Let's share the screen, new share. Now we're going to type in the natural log 1.3, close the parentheses, and divided by the value 2, and hit enter. Is 0.1318118. So k is about 0, not 0. So it's 0.13118. And now since we have the value for k and the value for c, at this point, we know the answer for the part A. So the function that represents the population of the rabbit gonna be in the form of y equals c times e to the power kt. C is 100 and e to the power k, which is 0.13118 multiplied by t. The next part, we are going to find time that the population will be 200 rabbits. It means when the population will be doubled the original number, which is 100. From the formula that we obtained in part A, or y equals 100 multiplied by e to the 0.13118 multiplied by t. We are going to solve for t, where the y equals 200. So to solve for t when y is 200, we just replace the y on the left-hand side with the number 200. And next, we're going to solve for t. Solving another exponential equation. So divide both sides by 100. The left-hand side becomes 2 equals the right-hand side e to the power 0.13118 multiplied by t. And that means we are going to take the natural log both sides. The log and e will be reduced or will be cancelled. The left-hand side natural log 2. The right-hand side is 0.13118 multiplied by t. Recall our goal is to solve for t. We are going to divide both sides by 0.13118. Then t, which is the natural log 2, all divided by 0.13118. Put in the calculator. I'm gonna share the calculator screen one more time. So clear this out. So type in natural log 2, close it, and then divided by 0.13118. And the number comes out to be 5.28. And the unit is in days. So this is the answer. If the problem requests you to put in as one decimal place, so you're gonna have to round to 5.3 or 5.3 for one decimal place. It's a little bit over 5 days to get the population to be double from the original number of the population.